So today we are going to study our first topic, which is sequences. So we are studying sequences in R real number unless or otherwise stated. Okay, so first of all, what is a sequence? So sequence is nothing but a function from natural number to set R. This set R could vary. So now example of sequence, for example, the sequence n. This is a sequence of natural number 1, 2, 3, 4 and so on. Similarly, the sequence 1 by n is 1, 1 by 2, 1 by 3 and so on. And similarly, the sequence minus 1 raised to power n is minus 1, 1, minus 1, 1 and so on. Okay. So now we study the key concept of this topic, which is convergence. What does it mean when we say a sequence is convergent? Because rest of the topic are all going to be study about convergence of a sequence. So what is convergent sequence? So say a sequence xn is tending to L, or limit of a sequence xn is L. Then what do we mean mathematically is, for all epsilon greater than 0, there exists an m belongs to natural number such that xn minus L is less than epsilon for all n greater than m. So if we see, what does the definition says is, if L is a number, you can choose any neighborhood of L, as big as you want or as small as you want, after some finite number of terms, which is m, xm. Rest of the terms after xm will lie in that particular epsilon neighborhood. This is what the definition of convergence means. Okay, now we move on to the definition of not convergent. So जितनी important convergent होने की definition है एक sequence के लिए, उतना ही important not convergence भी है. इसे समझना बहुत ज़रूरी है क्योंकि ये बहुत सारे questions में use होगा. So not convergence means that you can find at least one epsilon neighborhood such that you cannot find correspondingly an m number कि सारी terms उसके बाद वाली, उस m number के बाद वाली उस epsilon neighborhood में चले जाए. So you cannot find such a number m. Okay, I would highly suggest that you really focus on these two definitions because these two are very important. So now a little theorem, which is that convergent sequence is always bounded. You need to write a proof for this. It is very easy. And is the converse true? Is bounded sequence always convergent? It may not be convergent, so you need to write a counter example for this. Okay, algebra of sequence, what we are doing is we are considering two sequences, xn and yn, where xn is converging to x and yn is converging to y. So now what we do is we do term by term addition, subtraction, multiplication and division. Our general 4 algebraic operation, we do them on sequences term by term. Then we wonder that what would the sequence xn plus yn would tend to. Similarly, what would the sequence xn minus yn tend to? So it turns out that xn plus yn and xn minus yn, they will tend to xn plus x plus y and x minus y respectively. Similarly, if we multiply two sequences term by term, then x and yn will tend to x, y. And for division, there is a special case, which is that y should not be equal to 0. In that case, xn by yn tends to x by y. So the proof for this one is very easy, and this one is, say, a little trick is involved in this proof, and this proof is really insightful. So you should definitely check out these proofs and try to do them by yourself. Okay, if xn is a convergent sequence which is converging to x, does that imply that root xn will converge to x? And similarly, would the converse be true? You need to check that and figure that out. Similarly, we do the similar analysis for root xn. So you need to check these two, whether they hold or not. Then we study something is called sandwich theorem. So what is sandwich theorem? That if you have three sequences xn, yn and zn, and they satisfy this relation that xn is less than yn is less than zn for most n. So for all n greater than m. Okay, for most n, because for the convergence of sequence, what really matters is the tail of sequence. So we say that for most n, for most n, this inequality holds. And with that, the condition that xn and xn and zn are tending to same limit, which is z, then yn will also tend to the same limit. So this is a very easy proof, but I would suggest that you check it out. Okay, now we come on to the topic of subsequence, which is a very intuitive topic. So as the name suggests, that subsequence, so it is going to be a part of sequence. So how do you find subsequence? Say, consider this sequence x1, x2, x3, x4 and so on. Okay, so you randomly pick terms from this sequence. So you pick xn1, xn2, xn3, xn4 and construct a new sequence. Okay, but the catch here is that ni must be an increasing sequence in order for xn1, xn2, xn3 to be a subsequence. For example, that consider this 1, 2, 3, the sequence of natural number. Okay, so first subsequence I pick out 2, 5, 7, 9. So all of these are in increasing order. I am not talking about the terms, but you see, this is second term, this is fifth term of the sequence, this is seventh term, this is ninth term. All the indices are in increasing order. So this is a subsequence. Okay, similarly here you see that you 3, 8, 11, 14. So this is x3, this is x8, this is x11, this is x14. So indices are basically in increasing order. This is also a subsequence, but here you see that we first pick the 8th term x8 and then we pick the third term. So indices are not in increasing order, so this is not a subsequence. So all you need to take care for to check whether a given subsequence is actually a subsequence is to check whether its indices are in increasing order. Okay, so what do we so in subsequence there is a very crucial theorem, and it is very easy to prove, and you should do that if a sequence xn is tending to a limit L, then all the subsequence of xn will converge to the same limit L. And even better, the converse is also true. That means if for a sequence all the subsequences are converging to a limit L, then sequence itself would be converging to the limit L. So definitely check out the proof for this theorem. It will be very useful for your concepts. I've come on to a very important subtopic of our topic, sequences. So what we are studying monotonic sequence. So monotonic sequences has two things, which is monotonic increasing sequence, monotonic decreasing sequence. What is monotonic increasing sequence? That xj is greater than xi for all j greater than I. What does that mean? Is your terms are increasing as they are moving forward, and monotonic decreasing means your terms are in decreasing order. Okay, so monotone, this property of monotonic this property of a sequence which is being monotonic gives you a very powerful result when it is combined with boundedness of a sequence. So a sequence which is monotone and bounded is definitely going to be convergent. This is called monotone convergence theorem. Okay, earlier we saw that boundedness was not enough for a sequence to be convergent, but if we add monotone to that, then definitely monotone plus bounded is enough for a sequence to be convergent. Now comes the theorem, monotone subsequence theorem. So what does this say? It is then we come to, personally for me, this is the most powerful theorem in the topic sequence, which says every sequence has a monotonic subsequence. So for this I would suggest that what you do is try to construct such sequence, because when I first time studied this result I was like, no, this can't happen. So I tried many sequences, but always I could find a monotonic subsequence, and we have a proof for that, which is known as monotonic subsequence theorem. And the proof for it is very interesting. It took me a while, at least 3 or 4 attempts to really understand it. So highly recommend to do this. Okay, so now we study about Bolzano-Weierstrass theorem, very celebrated Bolzano-Weierstrass theorem. What does it say? That every bounded sequence has a convergent subsequence. It is very easy to prove once we get through this step, and you should definitely do this. That's it. To the final subtopic of the topic, sequence, which is Cauchy criteria. So first of all, what is a Cauchy sequence? So mathematically we say xn is a Cauchy sequence if for all epsilon greater than 0 there exists a k belongs to natural numbers such that mod xm minus xn less than epsilon for all mn greater than k. So ये तो हो गई mathematical definition. And what does it mean? It is a very smart and very intuitive idea. So basically when we were studying convergence, so to understand the definition and the idea of Cauchy sequence, let us consider this. Okay, so this is a road. Okay, there are 1, 2, 3, 4, 5 and 6 men are there, which are standing at 1 meter distance from each other. 1 meter, 1 meter, this is also 1 meter and this is also 1 meter. Okay, so I can fit and the distance between these two cannot change. Okay, so I can fit those 6 person into a room. If I were to fit those 6 person into a room, the width of that room must be at least 6 meter, right? Otherwise there is no way you can fit those 6 people. Okay, but those 6 people. Okay, what if I say that somehow I managed to fit those 6 people into this 1 meter distance? What would that mean? That would certainly mean that these people have come closer. The distance between them is also decreasing, right? If I could fit them into a room of width 1 meter, that means the distance between them is also decreasing. So that's how the idea of Cauchy generated. Okay, so let us see. In case of convergent sequence, we saw if xn is a convergent sequence to n, what did we saw? That you can find any epsilon neighborhood, that means any length, room of any length, epsilon length, and after chopping of finite number of term, you could fit in your entire sequence into that room. So what we are saying, that any room you can fit in, you can take any length epsilon, you can fit in your sequence, entire sequence into that epsilon neighborhood, right? After chopping off first m1 terms, that means that these terms are also coming closer, same way we did with 6 people, right? If they were not coming closer, there is no way they could fit in a room of any length, they could fit in a neighborhood of any epsilon. Is it making sense? So yeah, that's what we are saying here, that for all epsilon greater than 0 there exists a k such that xn minus xn is less than epsilon. That means that as you move towards infinity, the terms are coming closer and closer to each other. So there is a theorem which is that Cauchy sequence is always bounded. So its proof is very interesting and very easy. You should try to do that. You will gain great insights from this. So now the question comes, which is, are Cauchy sequence always convergent? So in this question, you need to find the answer for this question. Is it true? Is it false? And similarly, are convergent sequence always Cauchy? Is it true? If it is true, you need to write a proof for that. Okay, now a little and then there comes a little theorem that if xn is a Cauchy sequence and there exists a convergent subsequence of xn, then xn is convergent. It is very easy, but you should definitely write a proof for this to get a better understanding about Cauchy sequence and convergent sequence. That's how we end the topic sequences. Rest you will learn through examples, a lot of them. I would recommend you do a lot of examples and questions. And thank you for watching this video.